Diary, hello, it's 2021 and this is a companion video to go with my sale of my Seagate ST-238R hard drive. Now this is a 20 megabyte drive and it's not been used for about 10 years or more. It's been in my possession for at least 15 years, but I can't say the provenance before that. I did a lot of work with Cromemco systems over the years, and this was used for a time with other Seagate drives to test my Cromemco systems. So today we're going to look at the drive itself, and we're going to configure it back up for a Cromemco system, but of course when you buy it you can configure it and use it with any of those vintage computer systems that will accept an MFM style hard drive. So I've got the disk connected up. I think you can probably hear it kind of whining or spinning in the background. It's got a very characteristic sound. It's spinning quite nicely. That's the sound for a Seagate drive. And I'm going to now go into the Cromemco system at the RDOS prompt. We're going to do some tests at the RDOS at the sort of firmware level. Then we're going to boot the computer, do more tests and partition the disk. Okay, let's go. Okay, so that's the RDOS prompt for RDOS 3.12. I can press the T command to test the system, and we're going to test the H for hard drive. It's addressed at 0. Again, your jumper settings might need to change if it's not a Cromemco system. Okay, I hope you could hear that. That was first of all a long initial seek from one end of the hard drive to the other, and then some seek tests as shown on the screen here. Then we did a restore, and then we read some data, and now we hit enter to do the write test. So that's optional, because if you think you have a slightly defective drive at this point, you wouldn't hit enter, you'd hit escape to abort the testing. I'm confident. Okay, so the disk checks out okay. So we're now going to boot from the floppy drive. So we started with a memory test of the memory that's in the system. Another seeker, if you can hear that. So I'm going to boot from my floppy, so that's major device 1, minor device 0. You can see, by the way, if you we're booting from a hard drive, which would be my major device 6 and then minor device, for example, 0. So it's a fairly recently generated operating system, 23rd of May this year. I'm just going to switch off the automatic screen pause. Right, so we can read the label that's already on this hard drive, and we do that by issuing this command. So /dev/std anything is the where you address partitions on this disk, but std31 is a special name to access the whole of the first disk. And you'll see that we've got 4 heads, 615 cylinders, and we've defined some alternative tracks where we still have a separate area for tracks with bad data. So what we typically do is we want to reinitialize the whole drive. I'm going to scrub this entire configuration, and then we're going to check the entire disk, and then we're going to make allowances for any bad tracks by using the alternate track table. So the alternate track table, as you can see on the screen, starts at 6. I'm going to leave these settings. Okay, you can use init hard with a -n parameter, in which case it starts from absolute scratch and it asks you how many heads and cylinders and where your alternate track would like to start. Since the drive was previously formatted, we know what the geometry is. I'm going to just use init hard, hit enter. It's going to ask me what do I want to have a look at. I'm going to say ST-238R. It knows it's got 4 surfaces. It knows it's got 615 cylinders, counting from 0. And alternate tracks, we will leave it at 16. The starting cylinder of the disk for Cromemco systems is 1 because it stores this system information on track 0, so don't use 0. So we're going to start the cylinder for the, if you like, the data for the disk. It's track number 1. The last is going to be 615. So the write pre-put compensation is not used on this system, and that's going to be at the end of the disk. Effectively, we're not going to use it. And we are going to not initialize any tracks. I don't need to. So no for that. I am going to change the partition table. Why not? I'm just going to make it one large partition just to show you how all it works. So I want to change the partition table. The number of cylinders in the first partition, i.e. partition 0, I'm going to make it 610. As many as I can. So I'm going to just type that in. Alternate track location. So this is the place where it will remap on the fly using a software mechanism bad tracks. So if we find in a minute that track 511 is faulty, we can say map track 511, say head 0, to alternate track 611 head 0. So we're going to leave the alternate track location at 611. And don't forget, each cylinder has got 4 heads. So there's I've got 6, 11, 12, 13, 14. That's 4 tracks, but 4 heads. So that's 16 possible tracks, if you like. So I'll go for that. So, do you want to add an alternate track? No, I'm going to assume the disk is absolutely perfect. So, it's no for now. So now what we're going to do is we're going to use read all command. And we're going to say, of this device, STD31. And we're going to read the entire disk. We're going to read every byte of every sector of every surface of every track. And in doing that, we'll find out if any of these tracks are in any way in error. And if they are in error, we're going to remap them. So the best outcome here is that nothing is faulty. So you can see we've already got up to track 70. Sorry, I should say cylinder 70. So a cylinder is a vertical slice through all of the 4 surfaces 0 to 3. So again, we have 615 total tracks, of which we've got the 0th track, and which is going to have the system information and tracks 1 to 614 with our data. Now clearly this is a vintage hard drive, and we can't tolerate losing any data or having any data fudged or miswritten. So whilst this is a demonstration, if I was doing this in real life, given the age of the drive, I would first of all keep the drive powered on for about 30 minutes. I would run the read all command multiple times, and I would probably take the aggregation of any disk read errors and use those as the basis for my alternate track table. But this is a demonstration. We're going to get to the end of this full disk read, and if we're lucky, we'll have no errors. If we're unlucky, there will be some read errors, and we will remap them. Now it's important to notice that this drive was made in about 1980, so you're looking at a 40-year-old product which is still working, which is quite incredible in its own way. But in those early days there was no smart failure prediction, nor was there any kind of intelligent mapping of bad sectors or tracks on the drive itself. So this is purely going to be done by the host operating system, Cromemco in this case. So when Cromemco would access this drive with data on it, it would first of all it would read the information to say how many cylinders and tracks are on this hard drive, but it would also look at this alternate track table. So the alternate track table is going to say where these errors are on the drive and where they should be remapped to. Okay, so interesting. We have got some errors. So I'm going to write that down. So on surface 1 we've got 594, 595, 596, 597 and 598. So because I'm suspicious, I shall run that again, but I can use read all with all surfaces, and I can say minus cylinder, let's get this right, say between 590 and 614 of /dev/std31. So we do that again just to double check. Okay, so we've got 2, 4, 5, 6, 7, 8. So we've picked up another cylinder that could be an error. So we're going to run it again until we get well, you can see we didn't get 592 there. I'm going to run it again. Okay, so we take the superset just to be safe. So we've got 592, 594, 595, 596, 597, 598, all on surface 1. So we go back to the initialization program, init hard. The device name is STD31 to refer to the whole hard drive. He knows it's got 4 surfaces, 615 cylinders. It's got 16 alternate tracks across 4 cylinders actually. Again, this is standard. I don't want to initialize any tracks, thank you. I don't want to change any partitions. The alternate track location starts at 611. So I do want to add an alternate track, yes. So bad cylinder number is 592. Bad head number is, let's look at this here, remember these, you can see it on the screen, surface 1, cylinder 592. So I'm going to put in here, bad head number is 1. So again, this goes into a helpful loop so you can enter multiple problems. Bad cylinder number is 594. Bad head number 1. I'm just going to tick these off. Cylinder is 595. 1. Tick. We've got 596. 1. Tick. 597 1 and a tick, and lastly 598 1. So the last two entries is just a way of telling it to stop. So now you can see the alternate track table is populated. So this says that when the operating system tries to seek to cylinder 592 of head 1, instead you should go to 611 head 0. And if it tries to go to cylinder 595 head 1, again remap that please to cylinder 611 head 2. I think you can see all this all works. Do you want to add any alternate tracks? No, that's what we've just been doing. Do you want to delete any alternate tracks? No. So now we've finished, and let's look again at disk info of STD31. So now you'll see we've still got the same information about the disk parameters. We've got one partition now, which is all of 24,440 kilobytes in size, and we've got this alternate track table. Okay, that concludes my demonstration and little tutorial about how to use init hard and alternate track mapping on Cromemco systems. This disk is now for sale, and I hope you find it attractive. Okay, thanks for watching.